Greetings and welcome, friends. Today we're going to continue our look at dividing rational expressions, and we're going to divide more rational expressions. But I wanted to talk to you specifically about a kind of fraction or rational expression called complex fractions. Complex fractions. And this is my own little mini definition. It's complex fractions occur when you have, get this, fractions inside of fractions.
Mr. Running, did you cough at the beginning of this video?
I might have. It's fine. So fractions inside of fractions, it's kind of like fraction inception, fracception maybe? It's like a dream in a dream, right? So complex fractions are that. So what do they look like? Well, there's two kinds of situations of complex fractions. We're going to today focus on one. The first kind I call Stacko Frac. All right, and its general structure looks like this, where I have a little fraction up top and a little fraction down bottom. All right, and I'm intentionally kind of doing it in this general shape for purposeful reasons. So notice that my Gimondo vinculum is longer than the other two, just to make it clear, all right, what's going on here. I mean, technically you could figure it out, but I like that.
Was on the side quest, and that's what I'm thinking there.
So this top part you could call your numerator, right? This bottom part is like a denominator, right? And there is no language to describe the rest of them, but I came up with my own language to describe this and this, these guys, right? These two little denominators. I call them, ready, catch this, my own word, denominators. Denominators. Right, mini, they're tiny. Right? It's a pretty good word. Yeah, I didn't have as good of a name for the other ones, but I'll try. I was thinking I could call them, let's see, I need another color here. I could call this and this the new minorators. I don't know. That's the best I could come up with for that one. But I really like the word denominators. It's just awesome sound and really demonstrates the concept. So Stacko Frac is that situation. And today we're specifically going to talk about those. But there is technically a different type of complex fraction, which I guess I don't have a good name for. But it occurs when you have a sum or difference of fractions in fractions. Man, odd, gross capital F there. And so the general structure for that would be like if I had a fraction plus a fraction all divided by like another fraction, or maybe like another set of fractions being added or subtracted. All right, so this is like really crazy. Both of these are considered complex fractions. We're specifically going today target just the Stacko Frac situation. Why did I write stacked? Stacko Frac. Yeah, come on, what is this? I'll get rid of that T. There. I like the little O with the apostrophe specifically. Yeah, maybe that was going to be a K. It probably would make more sense. Yeah, it looked like a T earlier. Stacko Frac, whatever. So let's do a problem with the Stacko Frac, complex fraction. And this is going to be good. All right, example. Suppose I've got the following, 5a squared minus 20 divided by 2a plus 2, all divided by, big jumbo vinculum, right? 10a minus 20 all over 4a. Okay, so that's a Stacko Frac. Yes, there are plus and minus signs, but notice that this is all in the numerator of a single fraction. There's only a single fraction in the numerator and a single fraction in the denominator. Okay? Now, the technique, what was the technique we learned yesterday for dividing by a fraction?
Flip and flip.
Flip and multiply, right? So I'm going to, let's see, oh, all right, do I get decent quality here? Here we go, it's focusing on me. So this is the situation. I've got a Stacko Frac, right? So here's my numerator is up here, my denominator's down here. Here's my numerators, and here's my denominators, right? Denominators? Yeah. So this is the idea for a Stacko Frac. Let's do this, right? You flip the bottom and you multiply these two things across, right? Multiply these and these, right? So all you just do is like a little bit of this. It's pretty good. In fact, you can like do a dance move out of this. It's pretty awesome. It's pretty great. Feel free to use it. It's a good move, right? So the idea is you flip the denominator, multiply. Flip and multiply, right? So that's the idea. So let's do that for this problem. Flip and multiply. All right, let's do it. So 5a squared minus 20, and I could actually start factoring right now, but for the sake of our notes, maybe I'll just purely demonstrate this. So I flip the denominator for a, not 4d, over 10a minus 20. So what did I do? I flip this guy, and I multiply.
It's not 2a plus 20, it's 2a plus 2.
Thank you. Good call, good call. Haha, good save. So now I can just go through and deal like a normal problem with this stuff and just start factoring. So up top, I could factor out a 5, GCF that, a squared minus 4. Factor a 2 out of the denominator, a plus 1. Man, there we go. Multiply by 4a, I can't do nothing with that. And factor a 10 out of that one, 10 times a minus 2. Anything else I can do here?
Different squares.
A squared minus b squared right there, right? Difference of squares, so I can factor a little bit further. So 5 times a plus 2, a minus 2, times 4a. Might as well write it all over a jumbo fraction vinculum there. 2 times a plus 1 times, 10. So multiply by 10 times a minus 2. Right? And now I just go fruit ninja, right? So let's see, whooshing, whooshing, and 2 goes into 4, 2 and 2 once, 4 twice, and then check this out. 5 goes into 5 once, into 10 twice, and then what? Combo move, 2 and 2, wow! Man, that was amazing. Did you see those combos? Combo! Yeah, what's that, a pomegranate or something? I don't know, I've never actually played the game. And so I get a times a plus 2, right, was all that was left on top, over a plus 1. I don't need the parentheses in the denominator, because it's suggested alone by the vinculum, technically. So there you go, that's the idea. Really, it's not that much different, it just looks scary when it's a big Jimungo Stacko Frac. Technically, I could even like have you guys do like a challenge problem where you had like an even bigger Stacko Frac. Like, yeah, like that would be crazy. That would be awesome. But we won't do that. I'll have you get it at the end of the video just so I can keep it going and we'll come back. We'll come back. Let's see, so x squared minus 10x plus 25 divided by x squared minus 16 all over big vinculum 2x squared minus 50 divided by x squared plus 7x plus 12. All right, so huge Stacko Frac situation again. So what do? Flip and multiply. That's all I do. Ready? Ready? Here we go. What? What? Look, I'm not even looking now. It's amazing. So good, so good. So let's do that with this problem. And actually, simultaneously, I'm going to just start factoring it. So let's see, the factors of this are, oh, that's actually a pattern. What? I didn't even notice that. That's a squared minus 2ab plus b squared. That's not a b. Plus b squared. This is a difference of squares pattern, a squared minus b squared. Yeah. This one's a GCF, and this one's find the factors of 12, 1 and 12, 2 and 6, 3 and 4. It's going to be the 3 and the 4 that add to be 7. So let's set this up, and all while doing that, I'm going to flip and multiply. So here we go. Up top, that's going to factor to be x minus 5 all squared. Down bottom, that's going to be x plus 4, x minus 4. Multiplied by, now I flipped this one, remember, so this denominator is now in my numerator, right? So that's going to be here now, right? So that's going to be x with a 3, x with a 4. And let's see, those are going to be plus plus for their signs. We're so good at factoring now. And now this one I could factor out a 2. And before you guys write this, notice I'd have 2 times x squared minus 25. What's x squared minus 25? Difference of squares. So x squared minus 25 I could rewrite as x plus 5 times x minus 5. All right, so that one was both GCF, and then I did an a squared minus b squared on it. Right, so all sorts of factoring techniques coming into play. Feel free to write a bunch of factoring scrap work on the side if you need to. But I do not require it. So, Fruit Ninja time. Here we go. And let's see, x minus 5 cancels out with one of those. That was actually kind of an anticlimactic Fruit Ninja. Little anticlimactic there, I must say. So I'm going to have, what do I get? Up top, I got x minus 5 with an x plus 3 over 2 times x minus 4. I like putting the coefficients out front, and x plus 5. And we're done. We're done, right? So, I don't know, it's not that much different than yesterday. It's just the Stacko Frac can kind of look intimidating. And hang on to that concept about complex fractions. That will come back later on in the chapter, which will be pretty cool. Technically, actually a little bonus content here. There are complex fractions where you'd have like 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus, and you can actually have like this infinite complex fraction, and sometimes those can be used to define things like E or weird things like that. E, that'll come up later, don't worry about it. But yeah, so that's like an infinite amount of complexity in the fractions. So that's just kind of crazy stuff. And maybe what we should do just to end this proper is, in honor of our Fruit Ninjas, here we go. Go Ninja, go Ninja, go. All right, have a great day, everybody. That was so worth it.